Hello students. So today we are with a question from the CISE chemistry, class 10 chemistry sample paper. This is a question with respect to the mole concept and stoichiometry. This is a problem based on law of chemical equation. Okay, before diving on to this question, let us first make sure that our basics are clear. Okay, let's build up the basics which you will need to solve such a question. Okay, so let's dive into the basics. Basically, you should know that RMM of any compound, is equivalent to 1 mole. Okay, RMM of any compound is equivalent to 1 mole, and this 1 mole will occupy 22.4 liters at standard temperature and pressure. Okay, and this 1 mole will contain Avogadro number of particles, which is 6.022 into 10 raised to 23 particles, ions, molecules, etc. Okay, so this is the basic concept which you should be aware of. Okay, RMM of any compound, RMM is equivalent to 1 mole. Okay, RMM is equivalent to 1 mole, and this RMM will occupy 6.022 into 10 this RMM will occupy 22.4 liters. Okay, and the RMM contains 6.022 into 10 raised to 23 particles, ions or molecules. Okay, same is the case. 1 mole is equivalent to its RMM, and 1 mole will occupy 22.4 liters, and this 1 mole will contain 6.022 into 10 raised to 23 particles. Okay, and in another way we can conclude that 22.4 liters of any compound contain 6.022 into 10 raised to 23 particles, and this 22.4 liters is equivalent to 1 mole, and this 22.4 liters is also equivalent to the RMM of that particular substance. Okay, I hope this is clear now. This is a basic fundamental equation and the basic concept which you should be aware of in order to tackle all such problems related to chemical equation. Okay, so once again repeating, 1 RMM is equivalent to 1 mole, and this 1 mole will occupy 22.4 liters at standard temperature and pressure, and this contains about 6.022 into 10 raised to 23 particles, ions, molecule, whatever it is. Okay, now let's discuss with an example. Let us consider the case of oxygen gas. Oxygen, as you all know, the atomic mass is 32 grams, right? So this 32 gram of oxygen is equivalent to 1 mole. Okay, 32 gram of oxygen is equivalent to 1 mole, and this 32 gram of oxygen will occupy 22.4 liters at STP. Okay, this 22.4 liters is occupied by 32 gram of oxygen at STP, and this 32 gram indeed contain 6.022 into 10 raised to 23 particles, ions as well as molecules. Okay, in a similar fashion we can conclude that 6.022 into 10 raised to 23 particles is constituted by 32 gram of oxygen. Okay, and this 22.4 liters of oxygen is occupied by, volume is occupied by 32 gram of oxygen. Okay, and 1 mole of oxygen is equivalent to 32 gram. If you take 32 gram of oxygen, it will be equivalent to 1 mole, and if you take 32 gram of oxygen, it will occupy 22.4 liters at STP. If you take 32 gram of oxygen, it will definitely contain 6.022 into 10 raised to 23 particles, ions or molecules. Okay, next, nitrogen. Nitrogen, as you know, the atomic weight is 28 grams, isn't it? 28 grams of here, the 28 grams of nitrogen is equivalent to its RMM. Okay, and this 28 grams of nitrogen is called as 1 mole of nitrogen. Okay, and this 28 gram of nitrogen will occupy 22.4 liters at STP, and this will contain 6.022 into 10 raised to 23 particles, ions or molecules. Okay, I hope this basic is clear now. The next concept is formula for finding the number of moles. Okay, number of moles is given by the formula given mass divided by RMM. Okay, RMM, the relative molecular mass. Okay, so this is the formula for number of moles. Number of moles of any gas or any substance is given by the formula number of moles is equal to given mass by RMM. Okay, let's say we have to find the number of moles present in 64 grams of oxygen. Okay, we need to find the number of moles in 64 grams of oxygen. Okay, so the number of moles is given by here the given mass is 64, right? So 64 divided by, we all are aware that the mass of oxygen, sorry, the RMM of oxygen is 32 grams, isn't it? So upon cancelling we get a result 2. Okay, so the number of moles of oxygen gas present in 64 grams is 2 moles. Okay, and we know that 1 mole of oxygen gas will occupy 22.4 liters at STP, isn't it? We know 1 mole of oxygen gas will occupy 22.4 liters at STP. Now it's given that the number of moles is 2. So we need to find how much volume is occupied by this mass of oxygen. Okay, so we know that 1 mole occupy 22.4 liters. Therefore, the volume occupied by 2 moles is simply 2 into 22.4, which would be about 44.8 liters. Okay, so this given mass, this 64 gram of oxygen will contain 2 moles. Okay, 2 moles of oxygen, and this 2 moles will occupy 44.8 liters at STP. Okay. Moreover, we already knew that 1 mole is equivalent to 6.022 into 10 raised to 23 particles. Okay, so now we need to find the number of moles present in 64 grams. Okay, we have already found that 64 grams is equivalent to 2 moles, isn't it? 64 grams is equivalent to 4 moles. So the number of particles is simply 6.022 into 10 raised to 23 into 2. Okay, this would be the actual number of particles present in 64 grams of oxygen. It's simply just logic. I hope you must have learned the direct and inverse variations in your mathematics in grade 9 or 8. Okay, it's just simply the logic or the basics. You need to calculate everything for 1 mole or and then you will have to multiply it with the number of moles. Okay, since 1 mole of the gas or 1 mole of any substance will contain 6.022 into 10 raised to 23 particles. Now we have got the 64 gram of oxygen equivalent to 2 moles, isn't it? So it will be having 6.022 into 10 raised to 23 multiplied by 2. This much particles would be present in 64 grams of oxygen. I hope the basics is clear now. Okay. If you have any queries related to this, please do post in the comment section.